Hello, everyone. In this video, we're going to start at the top of page, what's labeled 24 in our workbook. And we're going to look at this box containing the trapezoid and midpoint rule estimations. So what we saw in the previous example was practicing using the trapezoid and midpoint rule, but then recall that follow-up, the part B, asked us to determine which was an over or underestimate. So we're going to do that here, but make it just a little bit, or we're going to talk about those over and under estimates, but try to make some more general statements. And one thing I will warn against, it's important not to just memorize boxes like this. What's important is to think through the reasoning and logic that we're carrying out so that when you're looking at your own types of problems and checking your own work, you can go through that same types of reasonings to see if your solution should make sense. All right, so let's go ahead and fill in this box together. So we have trapezoid and midpoint rule estimation. So let f be a continuous function defined on an interval from a to b. The first statement says, if the graph is concave up on that interval, then the integral is between what two values? So we're going to fill in here midpoint estimation and trapezoid estimation. But let's consider then which of these methods would be larger than our integral and which would be smaller. So to do that, let's look at these example graphs that we have drawn for us here. So we first look at the concave up situation because that's what we're dealing with here. So let's draw in what those shapes would look like, meaning if we did a midpoint or a trapezoid. Let's just use one rectangle because it shouldn't depend on how many rectangles we use. So if we are looking at this integral under this curve and we use a midpoint rectangle, the height of our rectangle will be right here. So we can fill that in. I'm going to use a solid, thicker line here. All right. Beautiful. So we have that line there, showing us the midpoint triangle rectangle we'd use. And then for my Zoom screen got away from me there. All right, so drawing in that trapezoid, again, we have the bounds of that trapezoid being here to here. And then how would that trapezoid look? Well, then we just connect those two endpoints. Okay, so let's take a look at what we're overcounting and what we're undercounting. So the midpoint, we're overcounting this area here. And fill that in so we really see that area. But then we're under counting in the midpoint rectangle all of this area. For the trapezoid, we're over counting all of this area. So can we determine then how we should fill in this inequality? So the true integral is here. So we can see then that the trapezoid approximation would give us an overestimate. We would count more than that area that we wanted to approximate. And the midpoint would give us an under. All this blue is all that area we're not counting. And that blue area is a lot bigger than this green area that we haven't counted. So that would be M sub n. So now let's do this for the next bullet. So now we're looking if a graph is concave down on an interval. Then how does the midpoint and trapezoid approximations compare with the integral? Well, let's do the same process for a concave down graph. So here we have concave down. So we can draw out a midpoint triangle and a trapezoid. So we can go ahead and fill those in. Height of our rectangle would be right about here. And then for our trapezoid, we'd have our end values, and then we connect. So similarly, let's go ahead and fill in what we haven't counted and what we have overcounted. So in the midpoint rectangle, we have not counted this area here. So we'll change that to blue because that's what I was using before. This is the area we have not counted. This is the extra area we've counted. And for a trapezoid, here's all the area we have not counted, but we wanted to. So let's go ahead and compare then these estimates using a midpoint rectangle and a trapezoid with the actual integral itself. So we can see pretty clearly that the T1, the trapezoid, is very much an underestimate of our integral because we wanted to include all that blue area. So in this case, Tn is actually going to be less than our integral. And if we notice with the midpoint rectangle, this green is a larger area than the blue area that we haven't counted. So that means M1 is giving us an overestimate. All right, so now let's finish filling in this box. So we have the error is the difference between the exact value of the integral and its estimate using either the trapezoid or midpoint rule. So that means specifically that the difference between the trapezoid approximation and the actual integral, so if we subtract those two values, we're getting the error using the trapezoid rule. So this is error, if I can spell error right, using Tn, and we actually have notation for this. We say E sub T sub n. So it's the error with the Tn approximation. And then similarly, if we compute the difference between our midpoint approximation and integral, we get the error using the midpoint approximation. So we write E sub mn. All right, so there you have it. And again, it's important that we don't memorize this box, but that we just learn to reason through the steps to confirm what is an over or underestimate, so that when we're checking our work, we can be confident in knowing how our estimates relate to the actual integral values. Thanks for watching.